By the end of this video, you will be able to run honest experiments with ExperimentLane, record a baseline, run one change at a time, capture the receipt of real metrics, and get a deterministic decision about what to change next. No more guessing, no more ABCD tests. Everything attributable. Here is the finished result: a lane, a baseline, an experiment, a receipt, and a clear winner named by the engine. Let's build that together. Before we start, here is what you need. Node.js version 18 or newer, and npm. That's it. No cloud, no API key, no account. ExperimentLane is a local-first engine. Everything lives in a JSON file in a folder called .experimentlane. You can install the TypeScript package, the Python package, the CLI, or the MCP server. In this tutorial we use the TypeScript SDK, and at the end I show you the CLI. To confirm your setup, run node-v and npm-v. If both print a version number, you are ready. Step 1. Create your project and install. Make a folder, initialize npm, and install the package, npm install at Talocode ExperimentLane. Next, define a lane. A lane represents one platform and its exposed metrics. For YouTube Shorts we say platform YouTube_short. The engine creates a lane with a unique ID, like lane_msldYXH_1. A lane also carries the metric priority, so the engine knows which signal matters most when it compares. Step 2. Record the baseline. This is the control. It is a snapshot of the metrics for your current asset, or explicit metrics you already have. We call createBaseline with the lane ID and the metrics object, views 480, average view percent 75, shares 10, subscribers 2. The engine stores it as the control point. Everything you change later is measured against this baseline. Note the baseline ID, base_msldYAYV_2. Step 3. Create the experiment. This is the heart of the discipline. An experiment changes exactly one independent variable. Here we create an asset, the piece of content or agent run we are testing, and then create an experiment with that asset, the baseline, and the variable we are changing, the hook. The engine records lane, asset, baseline, and variable. One variable. Everything else holds constant. That is what makes the result attributable. If the number moves, we know why. Step 4. Record the receipt. The receipt is the real, platform-exposed metrics that come back after the run. We call addReceipt with the experiment ID and the metrics that actually came back, views 624, average view percent 87, shares 14, subscribers 3. The receipt is timestamped and stored against the experiment. No manual judgment here. The engine compares the receipt to the baseline using the metrics the platform actually exposed. Step 5. Compare. Call compare with the experiment ID and the engine computes deltas for every comparable metric. It names a winner, baseline or experiment. It picks the strongest signal and the weakest signal. And it tells you the next experiment, change only shares per view, the weakest signal, and hold everything else constant. This is the deterministic decision that replaces the gut call. Absent metrics are simply unavailable, never a failure. The engine only compares what it can. Step 6. The guardrail. The discipline breaks when someone proposes changing two variables at once. ExperimentLane has a validator for that. Call validateNext with a proposal that changes the hook and the duration, two variables. The engine rejects it with code experiment_invalid, and the message, two independent variables changed. Change exactly one variable so the result remains attributable. This guardrail is what keeps your experiment stack honest, one variable at a time. Step 7. Take the next step. The decision block told us the weakest signal was shares per view. So the next experiment keeps the same lane and the same asset, changes exactly one variable, and compares against the same baseline. You can chain experiments this way, each one a single controlled change, each one attributable. Over time you climb the metric ladder, fix the hook, then the duration, then the thumbnail. Every decision is evidence-driven. Step 8. Use it from an agent. ExperimentLane ships an MCP server, so coding agents can create experiments, record receipts, compare, and read history directly from the model. The MCP tools are ExperimentLane Create, ExperimentLane Record Receipt, ExperimentLane Compare, ExperimentLane Get Baseline, ExperimentLane Next Experiment, and ExperimentLane History. The same engine is also available as a Python package, Talocode ExperimentLane, with an identical API. Step 9. The CLI. The npm package also installs a command line tool. Create a lane with ExperimentLane lane create, name my shorts, platform YouTube_short. Record a receipt with ExperimentLane receipt add, experiment ID, views, shares. Compare with ExperimentLane compare. And check the guardrail with ExperimentLane next, propose hook, duration. Every CLI command maps one-to-one with the SDK methods, so you can script experiments or run them by hand. Finally, Step 10, History. The ExperimentLane history command lists lanes, experiments, receipts, and decisions. The JSON store is plain text, so you can read it, back it up, or commit it. Everything is reproducible from the receipt onward. That is the whole workflow: define a lane, record a baseline, change one variable, capture the receipt, compare, and repeat. Step 11. Install from scratch, end-to-end. On NPM it is at Talocode ExperimentLane. On PyPI it is Talocode ExperimentLane. You need Node version 18 or newer for the TypeScript package, and Python 3.8 or newer for the Python package. No API key, no cloud account. Once installed, the package creates a local JSON store in the folder .experimentlane, and everything is persisted there. Step 12, the Python SDK. The API mirrors the TypeScript one exactly. Import ExperimentLane and JSON store, then create a lane with a directory. Create the baseline with the lane ID and the metrics object. Add the receipt with the experiment ID and the metrics that came back. Compare to get the winner and the next experiment. If you already know TypeScript, the Python SDK is a one-for-one translation. Before we wrap up, the common mistakes. Mistake 1, changing two variables at once. The guardrail rejects it, and the error tells you exactly why. Mistake 2, skipping the baseline. Without a control point, there is nothing to compare against, and the engine will tell you there is no comparable metric. Mistake 3, trusting a single metric. Let the engine pick the weakest signal, and change that one next. These 3 mistakes cover most failed experiments. Let's recap. ExperimentLane is an evidence-driven experiment engine for AI agents. You record a baseline, run exactly one change, capture the receipt of real metrics, and get one deterministic decision about what to change next. 2 commands to remember: create baseline, and add receipt. Then compare. Everything else is guardrails and history. The package is open source, MIT licensed, on NPM and PyPI. The next step is to run your first experiment. Install the package, define a lane for your platform, and record a baseline before your next change. If you want to learn more, the documentation is on the repository, and the full source is on GitHub at talocode/ExperimentLane. Thanks for watching. Run honest experiments, one variable at a time.